Good morning, everybody. Sorry for starting late. Other teachers needed some immediate help with some stuff, so had to take care of that. But I am now all yours. What are your questions? Yes.
Was electrical power even like chapter 27 topic?
Yes. You asked me a number. No. Yes. No. Chapter 26. 26. It's numbers. It was in the chapter with resistors, which I think is chapter 26, right? So capacitance was chapter 25. This was circuit reduction with resistors, I think is 27. Oh my gosh, I hope I'm getting this right. Potential's 20. We started with 24, right? It was 24, 25, 26, and 27, right? Okay, so electric potential integral set, that would be 24. Electric, this is 24, 26. Kirchhoff's rules is 27. Conceptual, this would be 26. And a resistor circuit analysis, I'm pretty sure was 27 also. Yeah. Admittedly, in my brain, 26 and 27 feel like the same chapter to me. So, yeah. Yeah.
So in chapter 24, you brushed up on partial derivatives?
A little bit, yeah.
Huh?
Yeah, we did.
Are we going to have to?
No, it's not on here. It would have said electric potential from, or electric field from electric potential or something like that. Yeah, so no. Peter? Yeah.
Could you do 10G on that one?
10G? It was that, okay, it was that problem. 10G. Be patient with me. I'm using a new system today to record stuff here, so let's see if we can get this to work. Last time it was an absolute disaster. This is not what I want. This is what I want. 27. Quick question. I got some feedback from this. I've been having trouble getting assignments to open up like in Safari or Microsoft Edge on my iPad when I go to Canvas through the browser, but I can get it to work in the Canvas app. Has anybody had success opening Wiley Plus assignments outside of the Canvas app? Yeah, what are you using? That's what I'm talking about. Like if I like open Safari and go to here and it says click here to continue, it just shuts it down.
It does the same thing if you're using Firefox.
Yeah, well that's because on the iPad all of them use the same browser engine.
Yeah, that's how this happened on my computer. The way it fixes, like I click the Wiley course resources, then the homework.
Okay, and that sometimes sends it through. I should try that because sometimes it might be missing a cookie. You might be right, knowing how this works. The weird thing is that the Canvas app has to use the Safari render engine to work. So like I can't figure out why it's working in the app but not the standalone browser. Anyway, thank you for that. I will try that in the future. What was it? Number 10? G. Oh, well, there's the answers. Let's go to student view. There we go. Knew I was going to forget something. Number 10. G. What is the potential difference VA minus VB? So I can kind of fit the whole thing on the screen. Okay, we're looking at this point right here and this point right here, right? So how do I find like that potential, at A? How do I find the potential at B? there's several different ways to think about this, but I think that the easiest part is to really look at what's going on between these 2 points. And since they say VA minus VB, I would start at A and go this way, right? So that potential drop, VA minus VB, has to be the potential drop across resistor 2 plus the potential of the battery. So do we know the current in that branch? Is that something they made you find? Yeah. What is the size and direction of the current in battery 2? So we know what the current is right here. Is this too small for you guys to see? It's pretty small, isn't it? Yeah. Okay. I'll try and fix that next time. So we know that current. So if we go from I don't want my ruler, A to B, right? We're going that direction through here. It's kind of like following a loop. My loop direction and my current direction are in the opposite direction. So what do I write? Plus I2 R2. And then my loop direction is taking me from a positive to a negative part of the battery. Is that a positive or negative voltage? That's negative. Minus E2. And then I would throw in the numbers that I had for the problem and get that. There's a 50% chance I did it backwards. And so if that answer doesn't work, try the negative answer. But that should be it. Did you try that and it didn't work?
No, I'll try it.
Okay.
How did you find the currents for each of them? 'Cause I wasn't sure.
Find the currents for each of those. Let's do this and let's crop it and let's just get this part. Is that bigger? All right. So they ask us size and direction up or down, size and direction up or down. So they're letting us pick, aren't they? I get to pick both my currents and my loop directions here. So let's what do you want? Let's do currents first. Okay. So current. How many currents should there be? I'm seeing 3. I'm seeing like a current coming out of this battery. I'll call that I1. See, like maybe that one's I2 and this one's I3. Is that writing big enough? Not really. Okay. So again, I pick those, right? Those are up to me. The problem doesn't tell me and I'll be good. Okay. So now what do I define? Loops. Got to have current directions, got to have loops to be able to do a Kirchhoff's law problem. So I see 3 loops. My loops are loop number 1, loop number 2 on this right-hand side, and where's the third loop? It's around the outside. For loop number 1, I'll do clockwise. For loop number 2, I'm going to do counterclockwise, and for loop number 3, I'm going to do clockwise. Does the actual direction matter? No, right? You just pick, okay? I went with what feels good, and what felt good for me in number 1 was kind of following the same direction as current 1, right? What felt good for 2, well, I made I3 go up that way, so I'm going to make 2 sort of circulate that way, and then 3's just messed up. Okay, so now I write down junction and loop rules. So for my junction, I got 2 junctions, right? At A, I1's coming in like this. I3 is coming in like this, and I2 is coming in like that, isn't it? The way I pictured it here. So what do I write down for the junction rule? What is the junction rule? In equals out, right? So what's going in? All 3 of them, right? And what's going out? None of them. What do I know? One of these has to be negative, right? I can't have 3 currents all going into a junction and nothing coming out. So it means that I have picked wrong for one of the directions of my currents here. So do I go back and restart the whole problem? No. The math will work out. It's just I'll get a negative current. And what does the negative sign mean? I just got to flip the direction of it. That's it. The magnitude will be the same. So I'm going to stick with my guns here. It's okay. I know there's not something right here, but it's a negative sign issue, but the conservation laws got my back. It'll all work. Now, we could write down the same thing for B, right? Because at B, they're all going out, but we'd end up with the same equation. It's all the same wires coming, at different spots. So I'm not going to bother to write down the junction rule for B. All right, loop rule for number 1. We're going to get to 0 eventually, so we'll start with that. Start at the battery. Positive or negative, E1? Okay. How do I know? Conventions, right? When moving from the negative to positive, if your loop direction takes you through a battery from the negative to the positive terminal, that's a positive, isn't it? Up here, my current direction and my loop direction are the same, so negative. Over here, my loop direction and my current direction are opposite, positive. Here I'm going through the battery backwards. Do you get that, right? Applying those rules consistently means that the math will work out, even though we've guessed wrong on the direction. So what did I say? Negative I1 R1 plus I2 R2 minus battery 2. And now what's going on down here? My current is this way, my loop rule is that way. So that's a negative I1 R1 also. I basically have 2 I1 R1s there, don't I? So I can clean up that equation to E1 minus 2 I1 R1 plus I2 R2 minus E2. There we go. And I've probably been given numbers for some of, I've been given those voltage. I could put numbers in at this point, but I'm not going to. Let's go to number 2. Start at battery E2. Positive or negative? Oops, positive. Negative I2 R2, yes or no? Current is going up, loop direction is, no, I'm going wrong. Oh, geez. Mr. Balogh, start all over again. Jeez. My loop direction was going the other way, wasn't it? Let's start at E3. We could have started E2, but that would have started off. I don't want to do that. So let's start over here at E3. So we've got E3 being positive, and then negative I, that doesn't look like a negative sign, negative I3 R1. Coming around, so I'm going this way. Coming around, my current and loop direction are opposite. So positive I2 R2. And then negative E2, because I go through that battery backwards. And then I pick up another R1 I3. So I'm just going to write a 2 right there. Am I going too fast? What am I doing? Three I'm not doing it. I'm doing 2.
I thought you just said you were doing 3.
Sorry, I might have said 3, but I'm doing 2. But current I3 is in that branch out there.
Why did you start at battery 3?
Personal choice.
Okay.
Personal choice. I tend to start at batteries. Just because I was taught that that's where everything in a circuit starts. Like the battery's pumping stuff, right? So start at the pump. You don't have to. You can start anywhere you want. So I did that one. Number 3, loop 3. Let's see here. The way you know if you have to do all 3 depends. Let's see here. I need 3 equations that are all, there's a word for this in mathematics. I can never remember what the rule is. System of equations is determined. Is that the word? So, like I think, let's see, I've got 3s and 2s, 1s and 2s, and a 1, 2, 3. Yeah, I think I have a deterministic set of equations here in that all 3 of those equations, like if I had an equation that was missing one of the unknowns, it's not a determined system or something like that.
Isn't loop 3 redundant because it loops loop 1 and 2?
Well, and that's kind of what Sammy's pointing out, right? Is like, do you really need to do that? Because sometimes, well, okay, I'm going to do it, and I'm just going to look at the math here for just a second. So if I do loop 3 starting at battery 1, let's say, so that's positive E1 minus I1 R1 plus I3 R1 minus E3, and then there's a 2 that one, the directions are all the same, yep, and a 2 that one. Okay, so what I did there, so I kind of quickly did it, I think I got it right, but this has I1 and I3 in it. This one has I3 and I2 in it. I think if you use 3, two, and the junction equation is probably the easiest system to solve. 3 and 2, 1 and 3, it actually doesn't matter. Using all 4 is overkill. It's not so much redundant, it's simply a question of how you want to go about solving it. It's good practice regardless, but like sometimes you can run into problems in circuits and it's best to over-determine your system and let the solver work with more than it is to have it be perfect.
Did you mean to write E2 like that in loop 3?
No. I meant to write E3 somewhere. I did E1, I did 2, I went through that. This was supposed to be E3. Thank you. Now, how do you solve for these? Linear solver, calculator. Like you could do long form algebra here, but I wouldn't, right? To get your homework done, throw it into Wolfram Alpha, maybe, does the Wolfram Alpha have an easy way to do systems of equations? I don't think so. Well, it probably does. They've changed it a lot. I'm used to doing it in Mathematica coding language. But anyway, that linear solver I showed you is a more friendly way to do that. But yeah, that's what I would do, right? And the linear solver doesn't give you the right answer. If your calculator doesn't give you, then there's either something wrong with how you've set it up, or more likely how you're telling the math to do its job. And if you've had linear algebra, you can do matrix method. Reduce your matrix down to 1s across the diagonal. I always hated doing that. Yeah.
So, I believe it was either question 7 or 8, part B. You would have to get.
Okay, I'll look it up here. Are we done with this question? Did I answer everybody's questions? Sort of. So like on the exam, I probably will take you to this point, or if I asked you to solve it, I would either give you an easier situation, or I would tell you like what like current 3 is. As soon as I tell you like one of these currents, it becomes 2 equations with 2 unknowns. And that's, solve it, plug it in, done. So that's what I do. Question? Okay. Which one was it, Peter?
Either 7 or 8. It was 8, not 8.
There it is.
So I was able to get A, C, and D, but B, I think screwed me over. I was just getting a wrong value.
The value or sign?
Value.
Everything. Who else wants to see this done in full? All right. 5 pages of trying.
How many loops for that one? I use only 3.
Let's see. Let's do. I'm just going to copy that much of it. What do you guys get? You guys don't get to see anything that I'm doing. Okay, that's fine. How's that? Is that big enough? How's this working for you guys? As far as the presentation on the screen, like, is it okay? Having to like copy paste on an iPad, which is something I hate doing. All right, I'll get used to it though. I kind of did this one a little bit already, didn't I?
Well, you showed the loops, but you didn't.
You showed the loop.
I showed the loops, but I didn't do the problem. So let's tap on that. Let's get a copy of it. Where is it? Oh, I want to copy it.
You're talking about in class, right?
Yep. And then let's crop it. Nope. That didn't work. Never mind. All right. There's a current. Got to define my currents. I'm going to do I1, I2. Can I do I3 that way? Does anybody object? No? Okay. Then I'm going to do I2 that way, I1 that way. Again, those are just guesses, right? And then loops. Loop number 1, loop number 2. You know what? No, I'm not doing those loops. I don't think they help. So I'm going to do this instead. Loop number 1. That's loop number 1. And it's going to be going clockwise. And then loop number 2. I've got 2. That captures currents 2 and 3, doesn't it? I avoided 1 by doing that loop. So now I need a loop that will capture 1 and 2. Got 2 and 3. Now I want, no, what happened? Stop. So we're going to go around like this for loop 2. And we'll make that one go clockwise also. Do you guys, can you follow what loop 2 is? I didn't want to draw right over the blue. But it follows the blue line, and then it goes from A to B, and then B to D, and then around. Okay. So let's see where that gets me in terms of loop rules and junction rules. And let's do junction rule first. Let's do junction C. Let's see, what do we got? We got I2 going in, and I1 and I3 going out, don't we? And then it looks like B is the same junction. Let's just check. At B, I've got I1 and I3 going in. Yeah. So those two ended up being the same equation. It's written in reverse, so that equation I don't need. Cross it out. All right. We could do other junctions, but I don't really care about. I didn't write down a current through the battery. Why not? There's no resistor in there. The loop rule, the Kirchhoff's laws for that the current through the battery doesn't matter. All right, so let's do loop number 1. Starting at the battery, that's going to be a positive voltage minus I2R2 minus I3R3 minus I2R2. Why are they negative? So my loop comes around, and my loop and my current are what? Same direction, right? So I make it minus. And then I come around this way. Again, my loop and my current are the same direction, so minus. And then my loop and my current are in the same direction, so minus. Clean that up just a little bit while I'm here. EMF, there's 2 I2R2s, aren't there? I3R3, okay, there we go. Loop number 2. Again, starting at the battery. Now I'm going to go minus I1R1 minus I2R2, and then I'm back to the battery. So that loop came around, went through this resistor, I1, loop direction, same direction, negative sign, and then came here, I2, R2 are in the same direction, so minus sign, and then I'm back to another one. Okay. There are more loops to do here. In other words, there's like a loop I could do that's like that one, but it turns out to mathematically be the same as the purple loop. And then if I do this loop, which is sort of the opposite of the blue one, again, mathematically it turns out to be the same. So how do I know that? I've been around the block a lot. And again, there's symmetry in this circuit, which is suggesting to me that I basically can draw a line through it and get the same equations. But again, we don't expect you to know that. You could write out all of those loops. It's good practice, but you'll end up getting the same equations. I think the black equation, this blue equation, and this purple equation are determined set. Don't even know if I'm using the right word there mathematically. Let's see. I've got an equation that links 1, 3, and 2. I have an equation that links 2 and 3. And then I have an equation that links 1 and 2. Yeah, I think all of those equations are enough to solve. Do I need to solve it? You want me to do the system? Do it in red. So we got to rewrite these equations in a way that the linear solver is going to work. So I2 minus I1 minus I3 equals 0. And so that's a minus 1 I1 plus 1 I2 minus 1 I3 equals 0. So I've kind of set, I'm looking for the coefficients in front of my unknown values here. In my problem, I've got 11 volts. And then I've got some numbers here, right? So this is minus 2 I2 M3200 minus I3 times 4250. So what does this look like? This looks like 6400 I1. If I move the I1 over, it becomes positive. Plus 4250 I3 equals minus 11. No, equals 11. So I didn't move the 11. All right. So I've set the blue one up. It's I2, thank you. I2, I got too excited. I2, I3, thank you. All right, and now the purple one. See, I'd fail all my tests if it weren't for you guys. 11. Never mind that lecturing is basically like taking an exam every day of your life. Because I got all of these people, smart, beautiful people that look at me like I know what I'm doing. It's like an oral exam all the time. I1, R1, 2,600, minus I2, which is my unknown, times R2, get the right numbers in here, 3,200. All right, let's clean that up. 2,600 I1 plus 3200, bad handwriting. I2 equals 11. Again, I'm just trying to set it up for my linear solver. Do I have linear solver in here? You're just going to do this over and over again, aren't you? Linear solver right there. All right, and I'm going to do the individual method. Can you guys see what I'm doing on the screen? It's a little bit small, isn't it? What have I got? -1, 1, -1. And then for my second equation, what's I1? It's a 0. So 0, 6,400, 4,250. What did I say? 4,250? And then it equals 11. And then back to here, what have I got? I've got 2,600, 3,200, and 0. 2,600, 3,200. And both of those were equal to 11. All right, solve the system. All right, gave me numbers. Gave me those numbers right there, annoyingly always as like a perfect fraction or whatever it wants to do. So we'll just quickly do that in the calculator. 1639, 825,800 divide. I got 1.98 milliamps. For I1, 1507 and 825,800, 1.82 milliamps, and 33, 206, 450. 0.16. All right. Those are what I got. Oh, wait. I found the currents. What do they want to know? VA minus VB. The voltage between this point and this point is going to be equal to what? I1 times R1. So VA minus VB, let's do this in a different color. Let's do it in black. VA minus VB is going to be I1 times R1. How do I know it's I1 times R1? If I look from here to here, this is the only element from between those 2 points, right? So it's going to be whatever that drop is. And it's going to be negative I1 R1. So what did I say I1 was? 1.98. So I better write it down. 1.98 milliamps. I2 1.82 milliamps. And I3 I got was 0.16 milliamps. This is so exciting. All right, so this is 1.98 times 10 to the minus 3 times R1, 2600. I should do this on the new calculator app on the iPad where it does all the math for me in real time, right? Has anybody messed with that yet? Does it?
Yeah.
I was hoping it would work. I haven't tried it yet. Does it kind of like do basic math?
Yeah, like algebra.
So I got 5.15 volts. Wasn't that annoying? What? Yeah. What is so VA is technically higher than point B because the voltage drops across R1 there. So they want the difference between A and B. That's going to be a positive drop. VA is a bigger, it's like 10 minus 4 is still 6, right? It's not negative 6. It drops across the resistor, meaning it's lower at B. So between A and B, I would say it's a positive drop. Now, if you guys told me it was negative 5.15, would I blink? No. What's the voltage across that thing? It's that number, right? Positive and negative is a matter of flipping the leads on your digital multimeter. Now that I got that one right, I'm pretty confident that the rest of it's going to be right. I'm not going to waste your time more, okay? But what you've got now on this recording is like a full demonstration of how to do your homework, right? With the linear solver and how to kind of put it all in. So you can go back and review it. Are you going to have a linear solver on the exam? No. Do you need a linear solver on the exam? No. I have I've written the problem so that you don't need a linear solver. Does everybody understand that? You do not need to know linear algebra. You don't need a linear solver. You don't need a fancy calculator. You are not at a disadvantage. Okay? At worst, 2 equations with 2 unknowns. Or if it's 3 equations and 3 unknowns, it's like super duper simple. I'm pretty sure it's 2 equations, 2. I wouldn't do any other thing to you. Okay? So it's either that or just set up the problem. Right? We'll find out how well I did tomorrow. I will determine that by how mad everybody looks as they walk out of the exam. Speaking of which, a question on this or?
I was gonna say, what was the integral step? Was that electric potential?
Okay, yeah, let's get to that because I want to talk about that a little bit. But before we do that, remind me to come back to your question. This week is a special week, right? What week is it? It's the 9th week of the semester. Something special about what happens in the 9th week of the semester. We're halfway through and there's like some sort of drop deadline, right? If you drop the course at this point, what do you get? You get a W. A W is an F as far as your GPA is concerned, right? But what it does is it enables you to like re-sign up for the course quickly, right? If you don't drop and you decide to drop next week or any other week after the 9th week, what happens to you? You get an F. You just get an F. And you need to go through a paperwork process if you want to retake the class, like if you want to sign up for the class before the next semester starts. That's basically what's the difference between a W and an F is. You are your own worst graders. You'll walk out of that exam probably grading yourself harshly than I would grade you. Don't do anything rash, right? You're getting the exams back after, we're doing the exam autopsy next week, right? That is after the drop deadline. So what I'm going to do, I do this whenever an exam's near the drop deadline. What I'm going to do on Tuesday/Wednesday is I'm going to do my first pass, which is always just a right-wrong. Like literally, I'm just kind of looking at your answer, and if it's wrong, it's wrong, and if I can't find it, it's wrong. like I just move through, and because I do a second pass where I go look at it in detail, trying to give you points back, that kind of thing. What I'm going to do this time is I'm going to do the right-wrong, which is always the raw score that I write on the front anyway. And then I'm going to post the grades on Canvas as if you have done the test autopsy. What does that mean? Does that mean that's the grade you're going to get on the exam? No, because if you don't do the test autopsy, the grade goes down, right? But in all likelihood, there will be things that I miss, which means that your grade will go up. But I want you to know kind of like the bottom floor, like the lowest grade you could be getting, right? Because really in the exam autopsy, it really, if there's any change, it's an upward change that happens in the exam autopsy, right? So what I want to do, and what students have told me in the past really helps them make their life decisions is, yeah, just do the right-wrong, Mr. Balogh, post the grades as if I'm going to do the exam autopsy, right? And that will help me know. I think that gives you a better idea of where you're at in the class, right? And I don't want you to go like all week beating yourself up over mistakes that you may or may not have made and then make decisions based on not having all the data. Does that make sense? Okay, so that's what I'm going to try to do, right? Try to get to you the grades by Wednesday. Is it final? Is the grade I post on Wednesday final? It's temporary, right? And if you don't do the exam autopsy, it'll go down. But if you do it, in all likelihood, it'll stay the same. Or when you find something that I've missed, it will. And let me tell you what's going to happen. Normally, I would go do a second pass, right? I'm probably going to be lazy and not do that. So you're going to be the second pass during the exam autopsy, okay? You're going to point out to me, hey, Mr. Balogh, you missed something, right? So the reason I'll be lazy is because I have 4A tests to do on Thursday. And I have to do them really quick. I got to turn those around by Friday so that, right, they can have the same thing. So I'm just trying to plan my week. Yeah. All right. Question about that? Integral setup. Integral setup. What is that? No. Okay. So it's electric. Where did I put it? It was a conceptual question. Integral setup, right there. It's right in the middle. That's why I couldn't see it. Okay. Electric potential integral setup. I'm just going to tell you right now that, no, come on. So what are all the integrals we set up in class? There was the line of charge, there was the ring of charge, and there was the disk, I think, where we did the integral setups. The line of charge was like a line of charge somewhere, and then like find the potential here or here or here, or find it somewhere, right? And again, that line could be like, I could stretch it along the y-axis. Like it's all the same method, right? You're using that. Our little piece is going to be our little dq. Our dq in this case is going to be lambda dl, so on and so forth. The integral setup method, that method of, add up all of this stuff to find out what the voltage is. Okay? And then it's a matter of like whatever point I'm having you find it at, right? Maybe it could be a point on the x-axis, right? So that would be the line of charge. The ring of charge, kind of already done, right? It's this ring, and then in 3 dimensions, right? Finding like on axis. And you know what? This is what you're getting on the exam. Okay? The ring, we already know the answer to. The disk, we already know the answer to, right? Integral setup. Be able to do a line of charge, right? Be able to find, like, if it's on the x or y, and then, pick a point, right, to set it up. The question will have, right, sort of in words what it is. It doesn't have a picture. It just has the words, like it's along this axis, along this axis. If you need a picture during the exam, just come up and ask. I'll try a picture. But you have multiple choice. I think there's 5 choices of integrals. So the integrals are all written out, right? You just have to identify which of those integrals is correct for that situation. Okay? So be able to do that, I guess. Did that answer your question? It's not meant to be like hard. It's meant to be like, that one. So we'll see. We'll see if that happens. We had questions. The same on this topic or different topic? Sammy. Number 13 on the homework. 13. I love this. It's a good problem. All right. Copy. Does anybody know a better way for me to do what I'm doing here, which is just copying and pasting into GoodNote? Yeah, I'm just screenshotting it. Okay, all right. And then you can't see it, but I paste it, and then, yeah, and now I go in and I crop it, which you can't see what I'm doing here, but
You could crop the screenshot too.
I can do that. Yeah, I can do that in the Apple screenshot. I actually find it's better to do it in here. Done. Because then I can just do this. Yeah. Cuts out some of the fluff. All right. But nobody has a better method, right? Workflow. You basically take a screenshot, put it in GoodNotes. Okay, all right. Because GoodNotes has no native functionality.
Do you copy it? And then like screenshot, copy the screenshot?
Okay, so I have a shortcut that I drag just from the corner of my iPad.
Yeah, that's what I do.
Okay, so I just drag from the corner, which puts it into screenshot mode.
I usually crop it right there and then just.
Okay, you could crop it. But doesn't that have you like, you have to like kind of do this stuff? And
Yeah.
I guess it's all right. Okay, but what I do is I just hit done,
Oh no, copy it.
copy and delete, because I don't want it to go. I just need it in memory. I don't need it in my photos. Copy and delete, right? And then I open up GoodNotes, and when I, hold on a second.
Are you trying to like paste it to the page?
Hold on a second. There's a thing. There's a way for me to show you what I'm doing on the screen. Mirror entire screen. There it is. You guys see my toolbar now? So now when I drop it in, right? It does that. If I now crop here, I know it's pretty small. Do you see how it says rectangle and freehand at the bottom? With freehand, all I have to do is draw around the stuff that I want. And then I say done. And all I've got left is I don't know. I just find the being able to do that a little bit faster than having to draw those, drag those rectangles. But you do you, right? That's what I do. Okay. But you guys think that's a good workflow-ish?
I think that's probably the best.
Okay, all right. You guys worked at these things more than I do, so. I normally run everything from the computer, and the iPad is the device that's controlled by the computer. I have to reverse it now because of my software is all changed. Anyway, you guys didn't want to know any of that. How do you do this problem? The issue, the thing that we want is right there, isn't it? We want to know the current through that resistor. And what was the clue I gave you? Yeah, to be amazed, right? So there must be some way to move through this circuit such that I don't have to deal with any of the other resistors except the resistors that are all right here in this path. Right? So, what do I do with these two resistors? They're in parallel, right? So what is that combination? It's R over 2. So the 1 over the equivalent is 1 over R plus 1, are all the same resistance, right? So that is 2 over R, and so the equivalent resistance is R over 2, right? So now, this is R over 2, this is R, and this is R. What do I know about the current through all three of those resistors? R, R over 2, and R. They're all the same because they're all in series, right? So I can just add all of those up. That's 2.5, isn't it? So 2.5 R is the total. And so if I can find the current through that 2.5 R equivalent thing, then I know the current in that single resistor. Okay, that leaves the path to take through this circuit that takes me on a path, right, through these resistors. So I'm going to start here and go down. Okay, so if I go like down this way, and now I'm just kind of doing a loop rule, right? I'm going to do a Kirchhoff's loop rule through this circuit. Going down, I know I have to go along that path because that's the path that contains the current I want to find. But do I want to do any other currents in any other junctions in any other parts of this? No, I don't want to do that. So follow my loop around. And what's the interesting thing about Kirchhoff's loop rules is that you don't need to know the current if you're moving through what? Batteries, voltage sources. So let's avoid every branch that has a resistor from here on out. So going through here, going up this direction, come around, go around this way. Looks like I can come around this way. And now I've got a problem, right? Because if I go along the bottom, what am I going to run into? That one. So let's go this far and then up and then over and then up and then over.
You should make this into a corn maze.
Corn maze. It's October. This is your corn maze. That loop right there avoided every single resistor in the circuit, didn't it? I will not give you something like this on the exam. I gave you this because it's a really good exercise in the power of Kirchhoff's loop rules sometimes in very complicated circuits, there are paths, right, that you can take to avoid having to do a lot of work. Part of the cleverness or joy or whatever electrical engineers call what they do is these kinds of puzzles. I personally hate them, but I tortured it with you anyway. Okay, so now what do? Okay, so I march through and I figure out whether I got a positive or negative battery, right? So as I come, starting here, coming down, I hit this first battery, positive or negative? Negative. Then this one's positive, positive, negative, positive, negative, 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 negative. Right? So now, I just kind of add them all up. 1. Looks like I've got 2 positives. Oh, stop it. Plus 2 positives, right? I just see that one and that one. Oh, nope, there's one right there. And I've got 1, 2, 3, 4, 5, 6, 7 negatives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 batteries that I went through. Okay, 3 of them were in the positive, 7 were in the negative, and then the part of my I got to get like I ignored sort of the beginning of this, right? I started here and went this way. That's going to be, and if I say that my current is flowing that way, little I, positive I, big I1, that would be a negative I1 times 2.5 R equals 0. So what is that? That's 4V on that side. And I've got 2.5 R times I1 negative. Yeah, this is a negative 4. It moves over, positive 4. So I1 is negative 4V over 2.5 R, which is negative 4. My problem times 11.2 all over 2.5 times 7.2. Multiplied by, I got 2.5. Nope. Amps. Amps is what I pushed. What's the is it up or down? I got a negative sign. So like, what? See how I said down was my direction for current, and I got negative for my answer. So what direction is it going? It's going up. Oop. You mean I can get those, Mr. Balogh, without guessing? Yes, you can. Other questions? I know you're annoyed that I sit down and do them in 10 minutes, but yeah.
The RC circuits, does that fall into the exam?
No, right? I would have said RC circuit. Yeah, if I was going to give you a time-dependent RC circuit, I would have put it down.
Should we review switches?
I mean,
Kind of included in resistors, but
there were some switches with the capacitor chapter or something where you had to chart. No, Like capacitance conceptual, one I don't think has a switch in it. But I'm not doing any of those things where like in the homework you switched on different branches of the, I'm not doing any of that. Switch is usually just a way, for right now, a switch is just a way to make a circuit harder or easier on the fly. That awful homework problem that has you adding branches as you go, right? It's like, yeah, okay. That has basically what a house is. But what can I ask you conceptually about capacitors? What have I modeled? Like, what have we done in class conceptually with capacitors? Do you remember the video where the guy had the capacitor plates and he was sliding them back and forth? So, could be that. Could be questions about like what dielectrics do. Like, what happens to the capacitance if you insert a dielectric? It goes up or down? Capacitance goes up. You can store more on a capacitor, right? How will that affect charge? How would that affect voltage? Well, it depends. Is the battery hooked up or is it not? Like, So that kind of conceptual question. And then the same thing like resistance conceptual. What happens to resistance if you make something longer? It increases. How do you know? Because resistance is equal to not density, but resistivity L over A, right? So the longer you make a wire, the more resistant. What happens if you make the wire fatter, like bigger in its cross section? Resistance goes down, right? Because that's in the denominator. Could be questions like, resistance, like what does it do? It's like friction, it's like viscosity, like a resistance in a wire. Where does the energy of the charge go? What does it get turned into? Heat. So those are the concepts surrounding resistance. Electric potential conceptual. We had a whole lab that was basically concept of electric potentials, right? You guys drew bird cages, you got confused by the Faraday cup, right? And you knew how to draw a dipole. So is there a good chance that you're going to be identifying maybe equipotential surfaces or looking at an electric field from a voltage? Yeah, we did a whole lab on it, right? So I would concentrate on that. What else in here is confusing you? Or is not as specific as you'd like? Yeah, short of just telling you what the question is.
I have a question.
Okay.
10 on 25 is those branches A and B, it makes those in parallel. 'Cause I got stuck on it because I thought they were in series, but
You don't need to worry about this for the test. But yes, this problem is a trap. And I've seen this problem appear in job interviews. Okay? Yes.
Oh my god.
Okay? This capacitor ends up being connected in parallel, even though it looks like it's in series. Okay? When these switches get closed, can't mark on the screen. When the switches get closed, okay, the charges equalize, don't they? Like the positive, let's say there's positive 10 over there, negative 5 over there. What would you get when they come together? You get 5, right? Okay? So that's positive 5 on the top, negative 5 on the bottom. So now you have two capacitors that are connected like this with positive, positive, negative, negative like that. That's a parallel connection. When capacitors are connected in parallel to something like a battery, okay, the battery puts out and dumps the same sign charge on the one side and the same size charge on the other. So even though it looks like they're in series, when you close those switches, the connection actually physically, as in physics, because both plates are the same sign, they're actually connected in parallel. So you add them together as if they're in parallel and go with it. This is a well-known conceptual trap for electrical engineers. It's called it's got different names, but I think it's called the reversed capacitor problem. And the reason it's asked on some job interviews, or I've seen it on some job interviews, is they're just trying to see if you know the obvious mistakes.
So is it because of the little branches coming off of it that makes it parallel, or that's what I
No, it has to do with the fact of what polarity the capacitors are connected at. They're both positive on top or negative on top.
went after the switch?
Yeah. So this one, the resistor cube, usually I've seen all of these like common misconception traps on like the skills portion of a job interview for electrical engineers. Some employers are very, very tricky. Southwest Airlines, this isn't electrical engineering, but Southwest Airlines will get like hundreds of applicants in for a position. And now that this is out, they don't do it anymore, but they used to. So you get 100 people in a room showing up for like 2 spots, right, in the company. They would filter out that room by looking at who smiled and laughed when a Southwest Airlines employee came in and started the like presentation, welcome today, these are the things you're going to be doing, and then would either make a mistake on purpose or a joke on purpose or something like that. And there would be a bunch of people watching, and they would take the people who laughed, that were not so anxious and serious and worried, but were in a pressured situation, could find the value of humor. Because Southwest Airlines valued that culture in their employees. I don't think they value that culture anymore. They just want to stuff as many people into a tin can, right? But it used to be that they would screen people based on their sense of humor, right, in a pressured situation. So yeah, applying for jobs is horrible. It really is. And now with AI involved, it's even worse, right? Because the AIs are screening your applications and doing all that kind of stuff. My son's been doing it for internships, and it's just bad. So my general advice is if you're applying for internships or jobs or something, meet people face to face. You're more likely to get in. I will see you tomorrow.